Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Consider the function f of x equal to x into sine of pi by x. What value must we give f of 0 in order to make this function continuous everywhere, right? So we have a function f of x and I'm going to call this function as x sine pi by x, right? Because let me copy that. Yeah. So let's understand before we actually jump into solving this problem. Let's understand why is this function discontinuous at a particular point, right? Now, if I notice that this is a product of two functions, right? If I look at, let me call them h of x, and let me call another function, say g of x, right? And what is my h of x is x, and my g of x is say sine pi by x, right? F of x is nothing but my h of x into g of x, right? Draw your attention to the algebra of continuous functions, right? I know that my h of x is continuous in x belonging to R, and because it's a simple linear function x, right? So I don't have to really worry about my h of x. What about my g of x, right? My g of x is a sine function, but I'll have to remember that my sine function has a problem at x equals 0. And why is that? Because I have sine of pi by x, right? And sine of pi by x is not continuous at x equals 0, right? And I'll take a minute to further explain g of x, right? Now, again, I want to draw your attention to the composite theorem of continuity, where we state that if there are two functions which are continuous and one of the function is say sine of x, and let me call it a of a of x, right? And let me call the other function b of x equals pi by x, right? And let me copy that. I know that my sine of x is continuous, right? But what about my pi by x? My pi by x is nothing but pi into 1 by x, right? And we know that my 1 by x is discontinuous at x equals 0, right? And I'm not going to go into the details here. So what happens if I apply the composite theorem to a of x and b of x, right? And what is my composite theorem? A dot b. And what is a dot b? I have a of b of x, right? Which means wherever I have x in a of x, I can replace it by b of x, right? So the function, I can comfortably say that sine of pi by x, right, which is a dot b, is continuous at all points except the point where b of x is discontinuous, right? So I have my a of x is continuous, okay, and my b of x is discontinuous at x equals 0, and my a dot b also is discontinuous at x equals 0, right? So, uh, so that is what we have, and I go back to my g of x, and we have concluded that my g of x is not continuous at x equals 0. but my h of x is continuous in x belonging to R, and therefore my h of x is, let me copy it here again, therefore my h of x, therefore, and what is my, is not continuous at x equals 0, right? And so that's how I arrive at the exact point where f of x is not continuous. Now let's go back to the problem and understand what is the actual question. So we've been asked what value we must give f of 0 in order to make the function continuous everywhere, right? So how do we redefine this function now? f of x, f of x equals, pull out my equation. Where's my stack bracket? I pull this out. I know that I can call this function x, sine pi by x, for x not equal to 0. And I've been asked what is it that I'll have to give f of x at x equals 0, right? So this is what we will have to figure out, right? So now for that, what do I need to establish, right? Again, drawing your attention to the rule book of continuity. For the function f of x to be continuous at x equals 0, I need to establish limits, right? I need to establish the limit in the neighborhood of 0, particular function. Limit x tending to 0, x sine pi by x becoming equal to f at x equals 0 will make this function continuous, right? Will make this function continuous, right? So all that we have to figure out is find out the limit of x sine pi by x as x tends to 0, right? I'll pause here for a minute because I'm going to draw your attention to a new theorem, uh, which we call it as the sandwich theorem or the squeeze theorem, which is going to help us solve this particular problem. It's not a very complicated theorem. I'll probably bring the theorem on our screen, and let's review it before we solve this particular problem, right? This is what my sandwich theorem states, right? So let's take a minute to read through the theorem. And if f, g, h are three functions defined over an interval such that g of x is lesser than or equal to f of x lesser than or equal to h of x, for all x in a deleted neighborhood of x naught contained in the interval, if limit x tending to x naught g of x equal to limit x tending to x naught h of x equal to L, then the limit of x tending to x naught of f of x also equals L, right? So in other words, we're just trying to understand why is this theorem called the squeeze theorem or the sandwich theorem, right? In other words, if f of x is squeezed or sandwiched between g of x and h of x for all x close to x naught, which again means the neighborhood of x naught, and if we know that the functions g and h have a common limit L as x tends to x naught, it stands to reason that f also approaches L as x tends to x naught. So this is what the theorem states, and I'm going to copy this part and I'm going to go back to solving the problem, right? So just give me a minute. So I know that for all values x not equal to 0, my sine pi by x will be a bound function, right? And what is that we mean by bound? It lies within a range. And what is that range for a sine function? We know that minus 1 lesser than or equal to sine pi by x, right? Pi by x lesser than or equal to 1, right? So as long as x not equal to 0, I have my minus 1 lesser than or equal to sine pi by x lesser than or equal to 1, right? Now if I multiply both sides by my x, right, what do I get? I will get a minus x lesser than or equal to x times sine pi by x lesser than or equal to x, right? So now I have this particular equation with me and I'm going to relate it to the squeeze theorem, right? Can we do that? The answer is yes, right? My g of x lesser than or equal to f of x lesser than or equal to h of x. And what is my g of x in this case? My g of x is nothing but my minus x, and my h of x is nothing but my plus x, right? Now, as x tends to 0, my limit, which is my second part of the theorem, right? I'm going to copy it here, which is my second part of the theorem, limit x tending to x naught, and in this case, our x naught is 0, and our what is our limit? Our limit of both g of x and h of x will also be 0, right? Because x tends to 0 and both g of x and h of x, which are minus x and plus x respectively, will take the limit 0. Now, for x sine pi by x, which is squeezed between since x sine pi by x is squeezed between g and h, the limit f of x, which is nothing but r x tending to 0, and our f of x is nothing but x sine pi by x, will also be 0, right? Right. So, so there we have figured out the limit, and I'm going back to what we wrote before jumping to squeeze theorem, right? And I'm going to copy this here. And what did we say? F at x equals 0 equal to limit x tending to 0, x sine pi by x will make this function continuous, right? And what is our limit, which we just established? Equal to 0, right? Because we just established that our limit is 0, which means my f of 0 should be 0 to make this function continuous. Right? So I go back, I have this function definition here, and if I want to define this function now, I can comfortably do it with the limits which I've just established through the squeeze theorem, right? So this is how I redefine the function in order to make it us at x equals 0. So f of x equals x sine pi by x for x not equal to 0, and equal to 0 for x equal to 0, right? So this is a good problem that helps you understand sandwich theorem. And I know that we've not discussed this particular theorem in the previous videos, and I thought this is a good simple example that helps us understand the application of squeeze slash sandwich theorem in problem. I'm going to put this theorem on the thumbnail, folks, for you to take a look at it before you actually get into my video. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.